This conference will now be recorded.
Hmm. All right. So this week we were going to talk about software bill of materials, or SBOMs. Um, I don't know what triggered this to come up as a topic, but we had it on the agenda anyway. And I think some of the discussion was in the past, if I recollect it correctly, was about S bombs and intercepts with TCG's proposal for CORIM and reference integrity manifests, and then what, if any, are the intercepts between both of these. So we'll just jump in to a refresher on what exactly SBOMs are. So the SBOMs initially came out of the U.S. National Telecommunications and Information Administration. Um, they've been in there, been worked for quite a while, and I think they kind of shot to fame with a presidential proclamation in 2001, I believe, of February or March of 2001, about the requirement for SBOMs and selling uh, software goods and services to the public sector um, in the United States. So, what are SBOMs? They're a point in time snapshot that describes, various components that are in software packages. Um, they come in various formats. You would think that the industry could align on a single format for such a construct, but absolutely not. Why would they do such a thing? Uh, it's much more complex to have to support multiple formats. So the formats that are available are that are, I guess, in the Telecommunications Information Administration spec are SPDX, Cyclone DX, and SWID tags. I don't actually have examples of what each of them look like in this presentation, but this actually links off to the various specifications, and we'll send these out late, later today after the call. So, um, the general purpose of the SBOM is to give consumers insight into what's in the package, a an inventory that provides some level of transparency, which helps with bug tracking. For example, if you buy a top level product or software package, you not knowing the subcomponents in it can make it very difficult for somebody to reason about their exposure to certain vulnerabilities. Like if you take the log4j or any vulnerabilities that have occurred in sub packages or sub modules of software components, uh, how you've got exposure to those when you don't have good inventory of subcomponents. So let's say there was an OpenSSL defect and you wanted to know where OpenSSL is used in your infrastructure. You don't have without some without having, of course, the source, and uh, without having some kind of information on hand to tell you what subcomponents are in all the software packages and firmware packages across your infrastructure. There's no real way to determine what your level of exposure is. Um, so they're designed to provide some form of transparency that gives you level of inventory. The value proposition, of course, is the transparency on the ingredients that are in there. the way some S bombs are constructed is it can also be used for integrity, as there are typically, not mandatory, which is another problem. But we'll get to that in a minute. There are measurements provided in most S bombs that are out there that help with package integrity. You can reference the SBOM and look at that, and then subcomponents that aren't signed, you can verify their integrity using the SBOM. So that's you know one nice feature. One of the challenges of a course is it's not a standard feature, it's not a required feature. Um, the other part, of course, is just that transparency gives you software identities where you can trace exposure back to known vulnerabilities when they occur. Why SBOMs have kind of come into to the spotlight is, of course, the requirements that we're seeing from different sectors. The big one, of course, was that presidential proclamation that I mentioned, requiring SBOMs. Um, the We're going to get to the minimum elements of an SBOM in a little bit. For me personally, I think the minimum elements are not, they don't go far enough. But of course, it is a minimum, not a standard. So it's hard to argue about it. Minimum, we always like to see the bar raised a little higher on that on what they disclose in SBOMs, but as a minimum, it's a pretty low bar. FDA has also published a draft on requiring SBOMs, and then we also see it in coming from UN regulation for a requirement for SBOMs. So it's getting out there. It's something that of course, we've already implemented conformance to inside in Microsoft, and where components and packages come in. Of course, we do sell goods we do sell goods and services to the federal government, so we take the requirements very serious when we get them. And that, of course, is going to stem out to our supply base as a CSP on meeting this level of requirement. Jumping into the SBOM and the minimum stuff, so I mapped it just to the fields here in SPDX as one example, but this is the minimum elements of the SBOM. The supplier name, the descriptions really of components, and some dependencies. You'll notice that the real security elements of measurements and signature to enforce integrity are kind of missing components, which is unfortunate in the minimum elements, but it is what it is. I mentioned that too. These are optional, not required, but measurements and digests of the firmware components would be really nice, as opposed to just human readable information about them, and digital signatures over the SPOM. Some standardization in that would be really nice too. And I know there's been some proposals on that, but right now it falls back to the underlying format and the mechanisms that they use. Um, so that's pretty much a super high level overview of SBOMs. And then the next part or thing that we wanted to discuss is like, okay, so we've got these SBOMs and these mechanisms that various requirements are coming from Europe, from the U.S. around requirements on for SBOMs for goods and services that are sold to governments. So we get all of those requirements and where they're coming in. Now, separate to SBOMs, and kind of started maybe about the same time was a similar to me kind of maybe a similar concept, but this is like a path we've explored in the past with with Cerberus and mechanisms like that, and having a notion of an integrity manifests that roll up into a platform manifest, and how we would go and reason about platform integrity and delegate policy control. So a similar initiative started in TCG. I published a specification on this, so it's out there. You can find it on the web for reference integrity manifests. And this is like hierarchical information. It is based on SWID tags. It is not an SBOM. It doesn't resemble a SWID based SBOM. Doesn't carry the same information that's required in SBOMs. So it's orthogonal. Um, RIM or reference integrity manifests, they rely on CBOR for a binary representation of of what we call machine readable manifests that can get expanded out from that binary format to like a JSON or XML format. There's tools that can convert CBOR to various machine readable formats. So the TCG spec composes of co-SWIDs and metadata in COSI format. So COSI is a CBOR object signing and encryption and standard that the SBOMs, or sorry, that that RIM uses. It also proposes some extensions in their hierarchy around module tags and hardware tags, and does a good job of organizing that like a really logical or hierarchical way of thinking about how components are constructed. The software hierarchy below. As the vision for it was really structure some kind of device attestation to make policy decisions similar to what we did in Cerberus. And then the goal was to have some form of comparative reference material that an attester or verifier could come along and do some kind of comparison and say, oh yeah, my policies apply, and the everything would provide these would spit out some CBOR information that could be converted into a standard machine readable format that a human or an attestation service could consume, and then compare to a bunch of references that are out there and published by like system or device manufacturers for the reference hierarchies. That was the vision, but the challenge that we've seen is we've kind of already done a version of this is you know measurements aren't that clean in the real world. Um, Measurements are typically uh, compounded. I don't know whether that's the right way to describe them, but shaws on top of shaws and measurements on top of measurements, capturing cumulative states, and it's really hard to decouple those without a log that gives you some form of chronology in terms of how those measurements were constructed. So another challenge is, of course, device measurements come out. They don't necessarily correspond to the binary you send in. So this is kind of one thing that appears in ASBOMs is, and I know that both are different, but One thing that appears in SBOM is like, hey, this is the binary measurement as it would appear on disk. Like this is the file measurement. So if you take the actual raw file, whereas when you when you ask a device for measurements, what comes out is something completely different to the binary that you sent in, and so some kind of translation is required between the two. Like an example is, you put your UEFI, you pay for UEFI or your BIOS on your system, and then you ask your TPM for measurements, and it describes that UEFI binary in seven different measurements, which don't equate, to the measurement of that binary, which maybe an obvious statement, but it's also where offline references and changes in variables and changes in execution path in the code. I mean, you don't generally get one set of measurements that says, "Hey, this is golden," and everything else is not. Um, there's a kind of an exponential factor to what could be considered golden, and you really got to understand um, the how those measurements are constructed and whether that path is golden or not. If there was only one good version of measurements, things of course would be very easy, and a scheme like this would be really really simple to go implement. But there's several possibilities for there's a lot of there's more than several. There's like exponential number of possibilities of good, and the same for possibilities of bad. So reasoning about good measurements and bad measurements is not trivial. There's generally two types of measurements as well. There's a current snapshot, which is like, hey, what's my latest version and my latest security configuration, and I don't care about everything that has gone before it. Just give me my current. And then there's the kind of more informative measurements that gives you the full chronology on what way you've been exposed to maybe various security settings, or what firmware versions that you transitioned through, and the order in which those things occurred, because that can lead you to a more, walking that same path can lead you to a more informed um, decision about your security posture. We call it here the firmware journey, and variable security state transitions. So, devices themselves at a low level, they typically have what I call poor recollection of change history. They don't have a lot of capacity to remember all of the state transitions that they've gone through. At least it's either resource limited, or it's just fundamentally a big design change in devices to try to have them record the uh, the history um, of the state changes that they've gone through, and then even if devices could automatically remember everything that happened to them in their history, determining whether that was a good change that exposed the device to some vulnerability, or uh, was was a good change that didn't expose the device to some vulnerability, or was a bad change that shouldn't have occurred and did expose the device to some form of vulnerability. That's a very difficult decision to make autonomously, or within a device, or uh, even at a system level, without understanding the without having insight into additional information as to why that change occurred, and the reason behind what that change was for. And then of course, RIM is not compatible with SBOMs. It's not designed to be an SBOM. its goal was something else. Um, it contains, the support module. I think they call it in RIM, or support package, actually does contain measurements, which is a good thing. Of course, the challenge is the order, and um, the order of those measurements and configuration changes, and how those get reproduced or reconstructed. Um, so coming back into to Journey, the summary here is kind of that seaboard to JSON. Yeah, is really neat. That conversion puts everything into a legible standard, but getting the real attestation data is, of course, the challenge for any verifier. And an example that I kind of put in here is one that I refer to a lot, is that when we think about microcode, so moving from microcode that's susceptible to um, to meltdown, the meltdown vulnerability and the Spectre series of vulnerabilities. So moving from a microcode version that's susceptible to meltdown to a microcode version that's not, is an is what we would call a hitless or an impactless update. You can just transition. You can boot on microcode version A that's susceptible to meltdown, and then you can patch to version B. But how do you know you've not been exploited when you run attestation across your systems and everything reports that it's running version B? That's a very simple way to think about the problem space, but of course it gets a lot more complex as we think about multiple state transitions, not just in microcode version ABC, where an intermediate version might have had some vulnerability that it exposed the system to, but also just normal state transitions. Somebody changes runtime variables, that changes the security posture. um, the 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 amount of change that's there is really difficult to determine, and getting that from a static manifest is not trivial. And I think those are challenges. If your attestation is really, hey, I don't care about uh, the state transitions, then you've kind of got a false sense of security in in how you attest. Um, yeah, it's the state transitions and what you've been exposed to is really what you want to get out of your attestation. Have confidence that you haven't gone through any state which left you exposed to could have compromised all assumptions that you're making on your attestation. So current snapshots of current versions are are great for the maybe the layman who just wants to take a look at, hey, my current system is reporting something that I expect. um, but in real world, it's a little bit deeper than that. In that cumulative uh, based measurement is more valuable, but it's also a little more onerous in terms of uh, really verifying what it means. Where you've got to get the TCG log or the history type mechanism and walk that. And of course, you could walk that and compare it to S bombs or co-rems, but that mechanism itself is of the cumulative measurement. I call it cumulative. I don't know what term we should probably put on it. Just measurements is how we typically describe it, but then um, measurements mean different things to different people.
So I think it sounds like, yeah, A, there's a big lift in that you need a lot of infrastructure to maintain and transport these logs wherever they need to be. Because like, yeah, as you said, like, the devices can't maintain these things. Um, you also like, unless you have an opinion about every entity in the journey, then the journey isn't really doing any good, right? So you need to have either some allow list in that these are all of the firmwares that I want to see in this journey, or here's a list of firmwares that I never want to see in this journey.
Yeah,
Because
exactly. And the order, the order too is important there, not just in allow list, but you may be allowed to go from A B C, but not C B C. If you know what I mean.
that sounds really complicated. I mean, like the sure, like I can see some cases of that, but just keep in mind, like
Rollback, right?
yeah, sure, the journey is going to be like you can never be too rigid on, or rather, hold on, you, you can be too rigid on the journey because your machine loses power and your journey will just reset and be totally different. So you can't have like a rigid policy saying I must have gone from A to B to C because you lose power and now your attestation fails.
Oh yeah, yeah. Absolutely. And you can't also ensure that you've gone from A to B to C because you may realize that B isn't sufficient, and I just want to go to C before you've updated the tail. As you roll out deployments across your infrastructure, you usually have some tail lag where, let's say it takes a day to roll out an update. Maybe halfway through the day, you decide to go to C. So some systems may have gone ABC and others may go AC. So I agree. You're absolutely right. You can't be rigid on the journey. But what's important in there is that you don't get unexpected rollback. And it's a little bit like the journey encompassing variable you know changes to settings that change the system's behavior.
Well, the
Um,
rollback question sounds kind of like a specialization of, hey, there's this, old firmware which is now in my denial list. I better not see it on this system in my journey.
may not be on the deny list always, yeah. But where some state is transitioned, that if you incurred a rollback, yeah, let's say you go forward and C adds a feature, and if you went back to B, it would create a vulnerability in that feature.
Are there like scenarios where we've like encountered this, or is this more like a hypothetical?
No, there's scenarios where we've done so we do so often we'll do what's called like a partial patch or update. Um, a partial patch or update to deploy a feature. So the whole feature doesn't go out in one shot, but goes out in a series of updates. And uh, like the URP mechanism using SMM for like automatically patching systems. Um, uh, that went out in a series of of updates that uh, we can't have rollback on.
In other words, I need to have been I need to be running my latest is what
Yeah, yeah, yeah. You need to be running the latest, and after that, we kind of seal it to the latest with like an anti-rollback.
so it's not
Um,
so much like going backwards as it's like what you want to protect against is not specifically going backwards, it's deviating from your target. Like if I went from A to B to C to X, that would be just as bad as going from A to B to C back to B, right?
um, maybe to see the X. So I don't know of a scenario where well, I'm sure there are some cases where you have to follow sequence. And we've definitely had updates in the past where we've had to follow sequence. Like I've had to go A, B, C, and I couldn't go A to C. Like we've had those updates in the past. Uh, not our own, but for devices that the firmware was authored by somebody else. we've had scenarios where it's got to be incremented in that sequential order, and if you break that, it causes problems.
like
Um,
security problems.
yeah, those are rare. We don't like that, but it's happened that way. And then we've had uh, updates that we don't want to have a go back on. We don't want to have a rollback. A rollback would expose a new vulnerability, and those are the ones where if you didn't roll forward, you're not exposed to the vulnerability. If you do go forward, it's created that vulnerability, and and not even sometimes a vulnerability, like an instability is which you can exploit as a vulnerability, but um,
So in the
yeah,
cases where like you must go from A to B to C, you cannot skip B. I just point out like that sounds challenging because like your logic now needs to be conditional. Like it's not like I must see B in my journey, right? If I cold boot C, I'm
yeah,
fine. But if I started at A, I then must see B. That's just a lot
yeah,
more work to encode in some kind of policy.
yeah, and it's tough, and we don't like those updates, as I said, but they do happen for sure. Yeah.
But in any
Um,
case, it doesn't sound like there can be one document format to solve all this.
uh, I, I don't think there can be a single document format, but I don't think everything in the in the in the CORIM specs is wrong, or the SBOM specs. I think what we ultimately need is measurements for accurate measurements from the device, and I think that that journey measurement would be the one. But then we need to have a log which helps us to interpret that journey measurement, and then um, without reasoning about what those measurements are, when you get like a code, a hash of code, it's like, well, what is that hash of code? What's in that, and was that secure? So that's where the SBOMs or reference integrity manifests can actually help, where you've got an endorsement of those things as you replay those measurements to build back to that top level PCR.
Sure. So like, and that will get you to like you parse your log and you get to some current value which you hope or what you enforce corresponds to your rim. But if you want to have special rules around, I'd better not see this particular version, or I better see them in this particular order. If A exists, B must exist just afterwards. That all doesn't sound like that can be just another rim.
No, yeah, that's logic at the verifier. He has to determine the rules, those policy rules. So yeah, at a station, verifiers is not an easy job that can look at an XML document and have like this aha moment and understand that he's okay. I think you've got to understand you know the the security posture of the device. It's not. I don't see it as something that's standardized anywhere today. And even can you get to a standard? Um,
So I wonder if we can, I mean,
I was going to
there
ask
is,
Brian,
oh, yes, sorry.
what are you looking for that's sort of not there now? I guess, right? Because if I'm building you a device and I'm shipping you the device, I'm shipping you some firmware, and I'm shipping you a RIM or an SBOM or something, I can tell you about the components and the things I'm shipping you at the time I ship them to you, right?
and
I
I
can't tell you about how you're using them in the field in your installation.
I think that's shipping me that information is great and valuable. But when I talk with the device, I need to get out of the device some measurements. And there's two types of measurements that we look for devices to omit. Uh, one is that um, current measurement that I talked about, maybe up here somewhere. I don't know where it is. Yeah, this current snapshot of latest version and security state. this one here is like not much different to looking at an SVN, but it can encompass. It's a measurement, so it can encompass more than the current SVN. It can pack a lot of attributes into that one measurement. And then the
But I
next one,
can't tell. No, but okay. So let's talk about just the current one before we talk about cumulative.
okay,
I can't tell you about the configuration state of your device in your fleet. I can tell you about the firmware binary I shipped you. I can give you a measurement for that. But I can't tell you whether you have secure boot on or off, or whether you want secure boot on or off. I don't know. That's up to you.
yeah, I don't want that information from you, Matt. I want that information from the device that you sold me.
Sure, yeah, the device has to report that, but this was about SBOM, so I'm kind of trying to figure out what you want in the SBOM.
Oh, yeah, sorry. Let me step back a little bit. The SBOM doesn't need to provide that. The device needs to provide that information, and I need uh, the device not to provide just this current level measurement that says, hey, your firmware is going to be X, your firmware measurement is going to be X, but your device is going to quote you, Y. Well, how do I understand what the device is actually saying to me? When a device gives out its measurements, it's not much good having. Well, I don't want to say it's not much good. There's value in having an SBOM with the artifacts that you ship, but how do I get from the measurements that the device is quoting to understand that secure boot is enabled, that debug is disabled, that firmware version is X? How do I get to verify that from those measurements? So what instrument gives me that breakdown that I can replay? Oops, I can replay a those measurements and build back to that current measurement.
So what you're saying is like the log mechanism is what you're looking for, because I think I was wondering the same question as Matt. It's like these SBOMs that tell you what binaries were shipped from the vendor. It sounds like these cumulative attestations and the verifications thereof are a completely different domain than vendor sends you some binaries.
Correct. And that's what I try to call out. Is SBOMs and RIM is different. SBOMs are about uh, verifying goods in supply chain on software mechanisms. So with the SBOM, it's actually describing the binary, which I describe up here. The device omitted measurements don't map to that. So what the device tells you doesn't map to the binary in your hand and your SBOM that accompanies that binary in your hand. Your
So are you
device, on
looking?
the other hand, tells you a bunch of other information.
Yeah. So like, are you imagining that there's going to be a RIM document which can represent, here is my allowed journey for this device at this time,
No, RIM doesn't give it either.
or even CORIM?
CoRIM doesn't give it. That's what it is. All CoRIM is device is quoting you in a format, a ultimately a bunch of measurements. It gives you some additional information, but it's giving you a bunch of measurements. And then
Sure.
how you determine good versus bad is out of scope.
Yeah. Sorry, I guess I raised that question wrong. Like, do you view as a gap that there is no document which describes a valid journey?
There's not even a document. I would say there's no methodology. And devices in the ecosystem aren't doing it. And that's what I see as a big gap in the industry. Like, so many examples where, hitless updates can get applied and, you get the current version and that's it.
Mhm.
So Brian, I wonder if this is like an extension that we need to do to the root of trust for update, right? We architecturally we separate between measurement and update, right? The measurement tends to be pre-instantaneous, whatever you have now, and that's what you compare to a core RIM, right? The history of what has been put on that device at which times, et cetera, seems to be something that the root of trust for update is the right place, right? But we don't have any documents for or any standard ways of tracking that, right? I install this and then I install that and then I install this other stuff, right?
Yeah.
Maybe that's where we should go.
I
Do you
I
think?
I, I think so, but I'd make one distinction in that the device shouldn't just give you that instantaneous co-rim because alone that's not sufficient. It needs to give you that cumulative PCR because if I store the log and a record of how things were changed and update in the root of trust for update, which is I think is a fine architecture and it's an acceptable solution. If I store it in that, what happens if somebody applies an update without going through the root of trust for update,
Well,
right? Or
yeah, the
change,
point is that you can't do that, right?
well, you know,
I mean, in theory.
yeah, in theory, but in practice, it's possible if you don't have the point of entry or the device itself omit just a high level PCR of what it's gone through. Like it's fine to make the root of trust for update say I have the log and the source of truth, but if the root of trust for if the log doesn't match the PCR emitted from the device, then something's happened outside of the root of trust for update. Um,
Right.
where I'm getting at. Whereas if I'm just getting what's emitted from a snapshot of right now emitted from the device, like in RIM, then uh, I miss there's a tax that I can orchestrate where I go version A B C and then I talk to the device and it says hey I'm on C but I don't know it transitioned through B and exposed me to meltdown.
Right. But I wonder if it is. It, the device does what it does today, right? It provides the instantaneous information. And then somehow there's a way in the when you go through the root of trust for update to have those same values as a reference, meaning every time you do an update, you would measure everything that the device had in terms of state. And you keep that as a reference through the root of trust for update. Then when the device reports stuff, right, you take the measurements from the device, and then the checking of those values is through what's in the root of trust, what the root of trust for update thinks should be. And if they're different, then you know there's a problem.
Yeah, but what if they're not different? What about the negative case? Let's say I asked the device for its measurements and it says I'm on version C,
Mm-hmm.
but the root of trust for update just has in it version C or version A, and then it has version C in it in the root of trust for update. So I make the assumption that the device has transitioned from A to C based on the root of trust for update, but those are separate devices. So what could have happened in reality is I booted on C, somebody performed an out of band update. They didn't go through the root of trust for update. They performed an out of band update, updated to B, made me vulnerable to meltdown, exploited my infrastructure, and then rolled me to C and went through the root of the root of trust for update to take me to C. Without the device telling me precisely its journey, I can't trust its current. And it could be something like somebody toggles debug on and off and mucks with it and then gets out. There's lots of attacks. I need to understand what the device is seeing, but the device doesn't need to keep the full record or the log. All it needs is the extension PCR. And that's the source of truth. And the root of trust for update with the log, as you walk that log, you should eventually get back to that cumulative PCR reported by the device. And if you don't, then you know you've been tampered with.
I noticed Brian Mullen from AMI had a hand raised earlier. I don't know if you still have that comment.
Sorry, I was on mute. Can you hear me?
Yes.
If I'm a verifier, can I use these measurements to uniquely identify a ROM image? So in the case of a UEFI ROM image? If I'm measuring the boot process, can I use like a accumulation of the measurements to uniquely identify a ROM image?
Like a mask ROM, or
Well, if I wanted to map it back to an SBOM that was released by the manufacturer.
you the answer there is kind of yes and no, but it's a little bit more nuanced. You could create a mapping that, hey, if the device omits these measurements, then it means it's running this version, but that alone is not sufficient for understanding your security posture, because measurements that aren't captured in binaries, um, uh, like there's multiple paths that your UEFI can take. So, for example, I can switch MRC debug on, or I can switch debug on via my UEFI binary. That binary is still composed good code, but the settings that I apply over it can put me in a very compromised, position.
Right. But the SBOM doesn't necessarily communicate security posture. It can communicate just inventory.
Inventory of the binary, yes, not
Right.
whether your device is in a secure state or has
Right.
always been in a secure
So
state.
that's the use case, is just being able to get the inventory of the binary. Can the measurements, and what you need to do is you need to be able to uniquely, a mechanism which will allow you to uniquely identify that ROM image.
Yeah,
If this is a reliable mechanism, then you can use that to reference an SBOM. So the verifier could use that to reference an SBOM, say generated during the build of that binary.
they could, yeah. They need that translation or that mapping, because the two don't add up, but they could do that, yeah. And then,
I just wasn't certain if the measurements measured everything in the binary. So if something isn't measured in the binary, then it wouldn't be a reliable mechanism.
oh yeah, there's a lot that's not measured there too. There's also uh, there's 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 generally state that persists, like so the binary, when you update your BIOS, all your settings don't necessarily refresh and you go back to like, oh, I wasn't configured this way. What they actually do is they have some persistent metadata that stays over updates, so it doesn't uh, looking at that binary doesn't tell you whether you're in a secure state or not. They have
Right.
metadata across updates, which gets cleared, when you pop the CMOS battery and you poke at maybe some other dip switches, but yeah, it's not a full view. It's better than nothing, but it's not a full view of your security posture.
Okay. All right. Thank you.
So going back to the cumulative PCR or register where you just extend this stuff,
Yeah.
what the main complication that I see with that is that you have to not be able to change it, right? You can only extend to it and not replace it or whatever. Now, when you have failed updates and that kind of stuff, that kind of situation where you have to go back and then you go forward, that would mess that PCR up in theory, right? And you can never put it back to whatever it was.
No, it should always just tell the truth on what's been attempted. So let's say I'm a device and I get an update and I take it in, I extend my PCR, I try to apply it, and it goes out. And then if I'm a device that somehow does like an auto recovery or rollback or doesn't apply it, um, I would still include that in the PCR.
Right. The problem is that the values now are also going to depend on situations that are specific to what happened in the, during the installation and all that kind of stuff that has nothing to do with, uh, in theory, the original updates, right? So the policies become a lot more complex to make sure if some, to ensure that something makes sense, that a particular value actually makes sense. If you have to go back and say, oh, there was this installation and we went back and we did this and that and that, and then eventually we ended up with this value for device A. But for device B that is identical to device A, there is a different value, and you have to see, oh, we didn't do that in device B. That seems hard for me to follow, right? Or at least to make it a tractable problem.
I think attestation is not easy. So that's why attestation only architectures. I've always claimed that they're flawed. Not only is it there's a lot of complex scenarios in it, but there's also attacks across it. Um, right? You typically want to attest that you've got a security posture and you can maintain that security posture. Um, but understanding that security posture is key.
Right, and
So,
I think you can attest that you have a security posture, and that's as much as you can do. And then the maintaining is sort of it's a different process, right? Where you, based on the state that you measured and whatever this thing is going to protect against runtime changes, right? But the attestation is definitely not going to cover any of that.
yeah, runtime changes today are a gap across a lot of devices, but that's one that needs to be addressed. Um, you know, in runtime with runtime updates. I think runtime patching and runtime updates is something that's been around for a long time, and it's really starting to break, reach a breaking point.
Well, and I think there's two things there, right? Runtime updates, at least there is an update, and then there's hopefully there's some history that you can leave behind and so on and so forth. But runtime changes that are due to vulnerabilities on whatever environment you're running, those don't get recorded as updates, right?
They need to, because that's a problem. If you look, it's not a problem that I can live with, because it's a problem that I sell on to others and they can't live with it.
Right, but the question is, how do you differentiate between this was legal and this wasn't legal? And I mean, this is part of a normal change in the system. You see what I mean? I
Mhm.
I don't think it's tractable to try to keep track of
That's
every single legal versus non-legal state of a device, right?
that's what attestation services have to do. It's not a trivial job. It's complex, and you have to understand it. And trivializing it with, like, converting from CBOR to JSON, it isn't a solution either. I don't care. My high order bid is not caring what format I get the measurements in. It's getting the measurements. I need the cumulative measurements. I don't care if I can do fancy tricks and convert from CBOR to JSON. That doesn't make me happy. I still don't have the real data. I need the real data. Give me the real data in any format. I don't care. Just give me the data and let me make decisions about security posture. Don't give me, tricks and, dog and pony shows. I need the attestation data. I want security, not feel good. I don't want theater.
No,
I
no,
want
understood. Understood. The complication is the more data you give and the more details you give, the more difficult it's going to be to make sense out of it.
Yeah, luckily I have computers that are smarter than me that can do it at a bigger scale, but I have to train them.
Yeah, exactly. That assumes that you can train them properly, right? And so on. So I don't know. What I wonder is whether or not we settle with, at the station goes up to this point where it's a static. You're getting basically a point in time snapshot of what's going on in that system, and all of the other dynamic stuff that happens has to be protected, but maybe at the station is in the current form is not the right way, right, of doing that, and we need something new.
Yeah, it would be very weak, to just have the current snapshot.
Well, yeah, it's not to say the current snapshot addresses the problems you're concerned about, right? It's just to say, no, it doesn't address those problems. It addresses up to here. And these new problems, we need a new way of addressing.
Oh yeah, yeah. I'm on board with that. Like saying, hey, this is what you get, and so to help people not make kind of false assumptions over what they're getting.
Right, and to be able to put some sort of bound into the amount of work that we have to do on the complexity, right?
Yeah, I agree. So we're kind of up on time. Jeff, I don't know if you need a time at the end or whether
Let's
push it
spend
next.
time in a follow-up meeting. Basically, we think we need to like do another round of like, okay, what are we going to really focus on and kind of narrow the field, so we can make progress on like writing white papers and getting specs out the door.
So you canceled next week, but the week after, do we want to take maybe 15 or 20 minutes at the start of that meeting so we get that covered?
Yeah, that would be nice. Let's see. Is Eric here? Can you guesstimate if you're still on like how much time?
How much? Um, that would probably work for me. Yeah.
Okay.
Okay.
All right. If not, we can kind of do that elsewise. But if you think you can spare
We could
15 minutes.
also shift. Yeah, Darpana and I have not had a chance to work on the BMC stuff, so if you want to shift, you can.
So,
Okay.
actually, that's an interesting comment. I mean, if you needed to do a couple things, we could shift it out instead of 1 week out 2 weeks, and that would be fine as well.
Okay, cool. So then let me just.
I'm expecting there's going to be quite a few questions, and there may be some feedback, so maybe that's a better way of doing it. So if we just pushed it a couple of weeks.
Okay, so that means next week is off because TCG. The week after will be planning and such. Week after that will be Crypto Center review. Perfect.
Good.
All right, thanks a lot, folks. I'll send the slides to Stuart. He'll send them out with the notes if Stuart was on. Maybe he wasn't on. All right, we'll get the slides out anyway.
Thanks, Brian.
All right.